So my name's Rob Woolley. I'm from Wind River, and David, Reyna, and I today are going to be presenting using Visual Studio Code with the Yocto project. So this is just a brief outline of what we're going to go over. I'll start with an introduction and talking a little bit about what Visual Studio Code is for anyone that isn't familiar with it. And then I'll start giving a bunch of demos because I think seeing really is believing, and we'll show how you could use Visual Studio Code yourself to do different tasks within the Yocto project, such as building recipes with Bitbake, debugging Bitbake, working with SDKs, and even doing remote development. And then we'll wrap things up with a conclusion. So first off, why did we start this journey? So when we walked around the office, we saw that a lot of the junior engineers that we were hiring were using VS Code on every single desktop. And when COVID hit, one of the things that we really wanted to focus on was how we can improve working from home. Because it's very different than physically being in the office, especially for embedded developers. So we asked ourselves, how could we adopt modern cloud-native tools? And we also asked, can we develop apps using SDKs? Because there's a whole world of people that are application developers and have never built their own distro from scratch. And we'd really like to attract those people and tap into all of those people building applications. And lastly, we also wanted to sort of give this presentation to show what's possible to the community to see if there's interest in building tooling in the community for VS Code. So what is Visual Studio Code? We'll start off with it's available for Linux, Windows, and Mac OS from Microsoft. And it's really a new IDE to replace things like Eclipse using more modern technologies. And that technology is Electron. If you're not familiar with Electron, it's built using the Chromium web browser and Node.js, and it's really constructed with HTML, CSS, and JavaScript, which is great because you get the flexibility of all these web tools, and it's easy to really sort of extend, and people that are coming out of university have the skills to do that. It enables code completion, debugging, refactoring, navigating your code, and everything you'd expect from an IDE. One of the other really compelling things is there are many useful extensions for embedded development already present in the Visual Studio Marketplace. And most recently, Microsoft just added support for Linux ARM v8 and ARM 64 targets. Sorry, not targets, development machines. So you could actually run Visual Studio Code binaries on your Raspberry Pi and your Chromebook to get your work done. Now that's all well and good, but if you're a tool developer, you might really want to know what's going on under the hood and why this is different from the setup you have right now with Vim, Emacs, or your favorite IDE. One of the things that makes Visual Studio Code different is this introduction of a language server and debug adapter architecture, which means rather than having all of these bits and pieces coming from different projects or vendors or providers, it's actually possible to interface them through the IDE and have everything working together. And this is very powerful because it means you can make your own language server in Node.js and tie it into the VS Code interface, and everything just works. The tools themselves are written in TypeScript, which is a strongly typed language that gets transpiled into JavaScript. A lot of the configuration is backed by JSON, so it's very easy to modify. And the source code itself is available under an MIT license, which is important to us because we want to make sure that we're able to use a tool and invest in a tool that will continue to be available to us. But there are binaries available from Microsoft under a Microsoft license. Now, if you want to really be completely free and open source, there is the VS Codium version, which are binaries that are completely compiled from the MIT license source code, and it even has its own fully open marketplace that you can pull extensions from. And lastly, if you develop an extension, you're not just getting locked into VS Code. Eclipse Thea uses the same extension model and can share extensions with VS Code. So I'll start with the first demo, which is really showing what the Bitbake extension provides in VS Code to allow you to develop recipes in VS Code. So start off, we'll just launch VS Code and show the terminal here. Now I've already checked out Pocky, and what I'm doing is running code -r dot to reuse the window. And now I'm going into the command palette and I'm setting up some workspace settings, mostly just to ignore some of the directories where there are lots of files, so VS Code doesn't go off and try to scan those. Next, we'll install the Bitbake extension from the VS Code Marketplace, which is quick and easy, and we'll add Python as well. So we'll go back and we want to source the OENet build env, and the extension actually uses this particular directory, VS Code Bitbake build. And here we're going to open up the conf local.conf. Now the important thing is in the settings before I specified we were using QEMU ARM64, so I just want to make sure the local conf matches. And now I'm uncommenting this line, which actually lets the extension loose, and it actually runs the backend language server. Now, this part might be a little bit cryptic. What it's actually doing is the NPM code is generating these shell scripts, and these shell scripts are using Bitbake and the various Bitbake tools to go off and query the recipes and the layers and other things that exist in the build. And you can see in the top that I ran in the terminal down below, Bitbake's going off and parsing all of the recipes and trying to understand what's going on. And this is the normal progress. This is where you'd see the normal progress bar where it's opening up all the recipes. So we'll just give it a moment as it goes through because that progress bar does take some time. I'll talk a little bit about what the Bitbake extension gives us. So the Bitbake extension is aware of the Bitbake recipe format and can do syntax highlighting for you, but it also is able to know what layers you're using, what recipes are present, as well as various Bitbake classes that are present. And you'll see later how it's able to use that information to make it easier for the developer. And you can see on the left-hand side, the project window is being updated as it creates different scripts, and it's running through all of these different executables. So this is what it was able to find: 3 layers, 780 recipes. And now if we go back in, we can actually show how this can be used. So I'm going to start by adding a package to the image that we want to create. And just for fun, I'm going to choose Vim. So see here, I get it from a drop-down menu, and it knows that Vim is a recipe. And now we'll do the same thing with inherit. I'm going to enable build stats. And you can see that it identifies build stats as a class and allows me to just autocomplete the rest. So that's interesting, but what about recipes? Let's go into the meta skeleton and pick up the bare metal hello world git. You can see you've got syntax highlighting. And if we go and do right click on this and do go to definition, it's able to bring up the BB class file corresponding to that, which is pretty useful if you're developing BB classes. So that's neat. The Bitbake extension is really good if you are a developer and you want to develop recipes and build things into your distro. But what if you're actually working on Bitbake itself? You're working with Python and you really need to be able to debug and know what's going on under the hood. Well, we can use VS Code for that as well. So this time, we're actually going to open the Bitbake folder itself because we're a Python developer and we want to focus on the Bitbake tool. So the first problem is that we have all of the Bitbake libraries and VS Code doesn't know anything about them because they're not in the standard Python path. So what we're going to do is create an environment file so that we can tell VS Code where those Bitbake libraries are. Now that we have that file, we're going to go into the settings.json and quickly just add 2 lines to tell VS Code where to look. Now, this is kind of confusing. The Python extension has created this setting called Python path, not to be confused with the Python path we just set. The Python path here is the point to the Python interpreter, but the end file will pull in that env file where we did set the real Python path, and now we're going to set up a launch so we can actually execute Bitbake. Use the existing Python template, and we'll just customize it to execute Bitbake. Now, the trick here is we're not actually in a Pocky environment yet. So first, we're going to set the arguments for the Bitbake command to core image minimal. We're going to set the working directory to the Pocky build directory. And we have to set the Python path here as well, so that when we execute the Bitbake command, it knows where to find the libraries it needs. When we set it before, that was actually for the linting and the source code analysis through IntelliSense, but here this is for the actual execution of Bitbake. Now, because we haven't sourced an environment from VS Code's perspective, we're going to point it to a file that actually has the environment variables that you'd get if you ran OE init build-env. And I'll just use a quick trick, a one-liner, to put the variables that were updated into that build-env file. And this is what it looks like. Notice I was able to open the file in VS Code from the terminal. Now that we have all that, we can go into the debug and run and start debugging Bitbake. So here it's firing up. You can see Bitbake and one of its threads in the call stack window. And we can pause it and take a look at what Bitbake's doing, see where it is, poke around at the variables, and let it go again. Now this part's interesting because it's parsed all of the configuration files. It's actually going to go off and launch the Bitbake server. So I'm waiting here just for that moment where it goes and kicks off the server and starts firing off the different workers. So it'll just take a second or two. Just checking for any output to make sure that it didn't fail. And there we go. So it's actually going and running tasks. And you can see all of the Bitbake processes there. So now here's the problem. When the Bitbake server got executed, Bitbake actually does a double fork, which throws off the PyDev debugger. So we need to attach to those new Python processes by process ID. So I used a quick template, and this is where I thought about using pgrep and realized you don't need to. You can just launch it, and it will tell you what processes are available, and we can choose cooker. And now we will pause cooker. So here, this is what cooker was up to at that moment in time. And you can see the debug console is frozen because cooker is not relaying any of the Bitbake worker events back to the UI. And when we let it go again, you can see the UI is updated again. So we can disconnect from that and stop Bitbake. Now, because we abruptly stopped Bitbake, I'm just going to make sure that the lock file is cleaned up, and it is, so we're good. Now, it's unlikely that you're going to be debugging Bitbake itself, but you might be using tinfoil to make some useful scripts to talk to Bitbake, just like the Bitbake layers command. So using the same setup, you can just change the program to Bitbake layers and run the show layers. And you can use this trick to make your own custom applications that are talking to Bitbake or Bitbake server. And that worked successfully, and it exited, so the debugger just told me it exited. So that's pretty cool. Now, if you're not building Bitbake recipes and you're not debugging Bitbake itself, you might be interested in actually using SDKs to develop applications. So for this next section, I'll start by just showing how you would create an SDK using Pocky if you've never done that before. You just go through your normal quick start setup with cloning the Pocky repository. If you want Windows SDKs, then I encourage you to clone the meta min.gw layer and add that in, and also just add some useful tools inside of the image. And then just run these commands at the bottom to build it for Linux and Windows. Now, even if you have these SDKs, VS Code doesn't know anything about how to use a Linux SDK. And that's where these JSON configuration files come in. So the first one is the settings JSON. That's your project level configuration file. And I use that to point it to where this SDK root is and let it know what the various triplets are. Then you've got the one that's specific to C and lets IntelliSense know what it should do. And you can set things like include paths and other things so that your code completion works with the SDK's header files, not with your system's header files. And then you've got tasks to do things like run the compiler and run make. And lastly, the launch JSON, which lets you launch things like GDB to do your debugging. If you want to see the full examples, you can check out this GitHub repository where I've uploaded numerous examples of different configurations you might be interested in. So let's see how these actually get used. So we start with VS Code. And I've actually installed a Pocky SDK already. And then I also added a kernel image and the ext4 image of the root file system. And you'll see how that comes into play later. And here is the clone of that repository I mentioned before, where we have a simple makefile and hello C example. And I even added a branch specific to Pocky for QEMU x86-64. So let's go open that. So here's our simple hello C. And here are those JSON files that I mentioned before, where we're setting the various configuration data. So this is a pretty basic example. I'm going to add to it just so you can see how VS Code uses this information. So let's go and add string.h. But notice I haven't closed it off. And there we go. It's warning me with that little red squiggle that I've made a mistake. I fixed it. And now we can actually find string.h as it exists in the SDK itself with full breadcrumbs to it. Let's go into the studio, the standard io.h. And you can see here we have an outline for these header files. So if you're looking up one of your favorite C functions, you can find it. Let's start doing some coding now. So I'll just add a few lines to this example. And you can see that while you're doing your work, VS Code is giving you different suggestions of things that you might be interested in. Let's get rid of this one and use the one on the stack. See, it keeps coming up with different red squiggles to warn me about different things, but then once I resolve them naturally, it just goes away. And it's relatively unobtrusive. So we're going to use the string char function to actually look for the W in the string. and get a pointer to that. And you can see as I use these functions, it pops up with helpful descriptions of what they do, as well as the function prototype information, which is always good when you can't remember which parameter was destination and which one was source. We're going to string copy Stonehenge into the string at that point that we found with string char. Now you may have noticed the lines on the left-hand side. It's actually using Git to track the changes we're making. Green is a new line and blue are the lines that were modified. So here we go. We compile the C file by itself, but I also have a make file, so I'm going to clean using the make file and then run a build task to do a full build using the make file. So we've got our hello executable now. Let's see what we can do with it. First, I'm going to launch QEMU using VS Code with the launch definition I have. It's coming up in our terminal. I'll log right in. Now I've set QEMU to map 1234 from the outside to port 1234 inside the VM. And we're going to launch GDB server here. Now we can use our GDB launch to actually upload the hello from the outside into the Pocky running inside of the virtual machine and start debugging it. So we've got our call stack, we have all of the local variables, and we can start single stepping through this. And as you can see, we've got the printf coming to the output of the QEMU launcher. Hello world and hello Stonehenge. There we go, we're all done. Now GDB server will remain open for additional connections, but I want to terminate it, so I've got a launch that it tells it to quit and it shuts that down. And that's done. So that's interesting, but those are things that you can get on Vim and Emacs already. It's been done for the past 20 years. What does VS Code actually bring to the table that's different? So the one compelling feature that really sold me was this understanding of remote development as something built right into VS Code. So what this lets you do is connect to some remote machine, VM, container, whatever, and when it connects, it automatically installs the VS Code server inside of that remote OS. At that point, it's as if you're using everything locally. You can navigate your project files, you can run extensions, you can even install extensions on the remote server that you don't even have locally. And this is very powerful. I've used this for accessing build machines that have 128 cores and tearing through builds. I've used it for accessing cloud resources on AWS, attaching to containers, and more. So the three principal remote extensions are remote containers to attach to Docker containers, so you have a reproducible sandbox development environment. There's remote SSH to connect to those build servers or cloud instances for cases where you need the additional compute power, and remote WSL, where you can use Windows Subsystem for Linux to give you a Linux development environment on your Windows machine. This is what it looks like. I don't actually need to demo this because it just works so seamlessly. There's nothing to demo. When you use it, the only sign that you have that you're connected to the remote machine are the things I've highlighted in red. And this is very powerful, extremely useful. And as I said, it installs itself the first time you connect. Most of the extensions I've tried will work with this just right out of the box. Some of them that are doing some more advanced things do need some help to work remotely. Now, if that's not all, the other thing that VS Code actually lets you do is leverage the cloud for some additional features. The first cool thing is this concept of development containers. So you can define a dev container JSON file and point to a container image on Docker Hub that you want people developing your project to use as the sandbox environment. So for example, if you release a Python application, you can provide a corresponding container image where you know all of the tools exist to build that application and run that application so that new developers can get started in minutes. An extension of that is the GitHub code spaces, which is currently in beta. So imagine being able to log into GitHub, you get a big green button, you click on code spaces, and then instantly in your browser, it actually launches VS Code in your browser using the container image you've provided for that new user, and they don't even have to install anything to your machine. They could be up and running with the Yocto project in a minute or two. And lastly, another useful feature which you might be interested in is the visual code live share. And this is what I'm using here on the right-hand side. My co-op student Vikram and I were talking about some work we were doing with build stats and some Python we were writing, and he can actually share individual files, just like it's Google Doc. We can review it, and we can both type into it or point things out, and we can see each other's cursor. And this was incredibly easy to set up. We just logged into our GitHub accounts, and we were able to go. So I'll do a quick demo just showing how you might use some of the remote features, particularly remote WSL2, to do development. So this is my Windows desktop. And I'll start just by launching VS Code. And I'm going to clone that GitHub repository I mentioned before. And I'm going to tell it to go here. Now, the main branch is really meant for Linux development. So the first thing I'm going to do is go and check out the branch with the configuration specific to using the Pocky SDK on a Windows machine. You can see I had to set rm equals del. And then if we look inside of these JSON configuration files, I mostly just had to point it to the right directory, escape the backslash, and also change colons to semicolons for the path lines. There is an issue that I'm pointing out here, just where I had to duplicate some of these variables because they don't get transferred between JSON configuration files. So we're all set to go. You can see here, even though we're on Windows, it's able to find the header file from the SDK itself. And we've got our hello C. And we can go up and we can do run build task and just build it with the compiler to make sure it's working. And as you can see in the bottom, we're using DOS style %cc% for the variables. I'm going to run a make target just to clean things up. You can see it's deleting it with del, and then run the build task and actually build through the make file. We saw that before. That's not very different. Let's do something different now. Let's go into the command palette and actually activate remote WSL. So I took WinRiver Linux, which is based on the Yocto project, and I turned that into a Windows subsystem for Linux distro. So you can see in the background, it's actually spun that up inside of WSL. The green in the bottom left shows that it's up and running. We can go in the terminal, and we're actually inside of the WinRiver Linux WSL instance. Now let's go get that hello file. There's a Plan 9 file system that's sharing files from Windows to Linux. And there we go. We just executed the Linux executable we compiled on Windows. Let's go and put that output in root output.txt. Now we're going to go to //wsl $/, point to the WinRiver Linux WSL distro, go to the root directory, double click, and now Hello World is showing up in Notepad. So not only did we use the user space that was generated by Yocto, but for added measure, I decided to go and put a Yocto kernel inside of WSL as well. So this is a 100% Yocto standard kernel with a bunch of virtualization features enabled, so things like the 9PFS work, and it just happens to be preempt. So those are some of the things that you can do with VS Code to make work with Yocto project more productive. This is really just a preliminary investigation, and there's way more work that remains to be done. I would love to work with the Yocto project community, with all of you, to sort of develop this further and see where we can take it. What I would recommend is we adopt and maintain this Bitbake extension. It hasn't really been updated in a year or two. Extend it to make it aware of recipes versus packages. If you were paying attention closely, you may have noticed that the image install append was looking up recipes, and I think technically those are packages at that point. Provide appropriate identifiers based on context like that, and maybe even extend it to provide recipe templates and support for recipe tool and dev tool. I also think there's a huge value in being able to create new extensions for VS Code to talk directly to Bitbake using things like tinfoil or XML RPC directly. You could create web-based visualizations for things like PyBootchart that would display either in VS Code or in a normal web browser. And we can enhance the SDK development workflow even more for application developers. And I also think there's a huge value in extending crops to leverage things like dev containers so that people can just start using Yocto right away, right from GitHub. And lastly, I'd like to give a shout out to the various people that collaborated with me on this. First, I'd like to thank Martin Bjorkstrom and Jürgen Wiens for developing the VS Code Bitbake extension. And I'd like to thank Joseph, Rudolph, Tim, Joshua, and David for all the valuable feedback they've given towards this over the past few weeks. And a special shout out to Anmol Singh Man, who's an intern working for David, who helped port the original proof of concept I did with Wind River Linux to Pocky. If you'd like to try this yourself, check out that GitHub link for instructions on how to try it at home using either Pocky or with Wind River Linux for Intel, Raspberry Pi, or Windows. If you are interested in trying it out, but not able to do a build of the entire platform right now, you can find pre-built SDKs and binaries for Intel and Raspberry Pi at the location below on Wind River Labs. That's my end of my presentation. Thanks for listening, and I hope you found this useful.